All right, guys, so this is the review solutions for section 3.6. This is work on solving quadratic equations by using the quadratic formula and the discriminant to determine the number and type of roots of a quadratic equation. This is my jam. I like this. I like this stuff. This is a fail-safe way to get your solutions if you're taking like an ACT test or any sort of standardized test or timed situation. This is probably your quickest, most efficient way, in my opinion, if you can't factor it quickly. So, given each equation, find the discriminant. So first of all, the discriminant is b squared minus 4ac. It's that little weird chunk of the quadratic formula. So, for this first one, this is b, this is a, this is c. This a, b, c. A, B, C. It's just in descending order. So, sorry, I should clarify here also, my bad. The discriminant is just the interior part. It doesn't include the actual like square root, but the square root is what tells you kind of what's going to happen, whether it's going to be rational, irrational, that sort of thing. So, the discriminant in this one is going to be b squared minus 4ac, like that, which is 25 minus 16 times 2 is 32, and then it's going to become positive because this negative times negative. So that's 57. That means that there's going, because it's positive, that means there's going to be two real roots. But if you square root the 57, so if you add that square root and you do that, it's going to come out as trash. That's going to make it irrational. So basically, if it comes out as garbage, like really messy, it's irrational. The next one, b squared minus 4ac. This is 4 minus 4 times 5 is 20. 20 times 4 is 80. Minus 80, this is negative 76. Because the square root is negative, that means it's going to be two complex roots. And again, if you add the square root part, if you try to square root that, it's going to come out also as trash. So it would be two complex irrational roots. And then this last one here, b squared minus 4ac, you would get 64. Negative times negative times negative is negative. 4 times 16 is 64. So that is 0. You're going to end up with one real, because it equals 0, one real root. And then when you square root this, it's not going to come out weird. It's just going to come out nicely as 0. So that means it's going to be rational. All right, so now they want us to find the exact solutions by using the quadratic formula. So I'm just going to start by rewriting the quadratic formula up here. X is equal to negative b plus or minus the square root, b squared minus 4ac, and then that whole thing over 2a. So what we would do is we would go a, b, c. A is 1, b is 45, c is 200. So we're going to go opposite b plus or minus the square root of b squared minus 4ac all over 2a. So then this is negative 45 plus or minus. When you put this into a calculator, you get 1225 over 2 times 1. The square root of 1225 is actually it's a nice number. It's 35 over 2. So I'm going to split this. Negative 45 plus 35 divided by 2. Negative 45 minus 35 divided by 2. So when you do this first one, you get negative 10 over 2, which is negative 5. When you do this, you get negative 80 over 2, which is negative 40. Oofta, this next one's a mess. It does not equal 0, so we got to do a couple extra things. We got to add 7x and add 4. Add 7x, add 4. So we're going to have 4x squared plus 7x. Negative 9 plus 4 is negative 5. Now it equals 0. Now we have a, b, and c. So we can go negative b plus or minus the square root, b squared minus 4ac all over 2a. So we get negative 7 plus or minus the square root of 129. And then that's all going to be over 8. The square root of 129 is trash. It's not really reducible. If you want the two separate solutions, it's 7 plus the square root of 129 all over 8. Make sure you include the negative 7. And then negative 7 minus the square root of 129 over 8. Don't do this, you guys. If you do this, it's wrong. A lot of students do that. You need to extend this so that the 7 is included, okay? So this would work, or you could write them separately. Either one. All right, and then last one, this already equals 0, so we can just go A, B, C. So x is equal to opposite b, which is a positive 3, opposite's positive 3, plus or minus the square root of b squared minus 4ac all over 2a. So then you get 3 plus or minus the square root. That interior stuff equals negative 87 over 6. So the negative in the square root is just mathematically gross. It's like bad grammar. So we would pull out an I in front and then make it a positive. That negative we manage with adding an I. And then divide it by 6. So this could be your solution, or if you're like me, you kind of like having two separate ones to make sure you understand that it's the plus square root 87, over 6, and then 3 minus I root 87 over 6. So either way would work.